Hello, everyone. My name is Maxwell Fertik.
And I'm Max Werner. And we're here today to present some of the work that we did over the summer focused on the evaluation of the disentanglement toolkit with a focus on the standard grapple. And I just want to say that we're really thoroughly amazed by the support and guidance of the small community that's given us these last few months. We want to thank you all for letting us play a role. So let's get into it.
So Max and I are both RISD graduate students in the Masters of Industrial Design program. And I come from a design theory and fine arts background with an emphasis on physical making and critical thinking. And now at RISD, I'm exploring avenues of critical design in the context of climate change.
And I come from an industrial design background and have experience in the 3D printing industry in the Boston area before coming to RISD. I'm interested in the possibilities of aquaculture and additive manufacturing. The two of us were first introduced to Ainsley and the whale disentanglement team and began discussing opportunities for collaboration at the beginning of the year in 2021. But it wasn't until this spring of 2022 when Max and I received funding for the competitive RISD Graduate Commons grant that we were able to begin work together with Professor Adam Smith as our RISD advisor.
So to begin, we want to outline what our broad goals were for the short period of time that we got to work together. So as we all know, North Atlantic right whales are critically endangered, and the present and future generations are consistently impacted by entanglements from different fishing equipment. So together with Ainsley and David, we learned how crucial it is for disentanglement teams to have a diverse toolkit available to them so they can best respond in this brief window of opportunity. However, many of these tools were largely made from whatever is available in a somewhat DIY fashion and iterated over and over, depending on their efficiency or efficacy. So we determined that our skills could be best applied in the following ways. One, to create CAD drawings and diagrams for the basic custom tools that were produced here on the East Coast. Second, to produce basic simulated stress analysis on the standard grapple and knives, which will eventually lead to recommendations to strengthen, reduce weight, use of alternative materials, and improve design on at least the standard grapple. And lastly, to work to find a local metals fabricator with both welding and casting capabilities and develop 3D printed models to demonstrate some novel methods of printing and casting the tools. And then kind of going into the larger goals, after doing some qualitative research on the intricacies of disentanglement from the Center for Coastal Studies database, we found that there are many adaptations and adjustments that we could touch on. But despite the varying techniques and location-specific variations on approach, we found that the standard grapple is really the workhorse of the toolkit and deserved the most focus out of all the tools. So we began to produce a series of prototypes from cast urethane that could be easily reproduced locally, as well as a handful of 3D printed pieces. These were not necessarily functional on the sea, but a demonstration of these techniques with possible educational applications. And finally, we hope to create a database of these methods and of many of the CAD drawings we produce for future collaborators to view, edit, and adjust accordingly. So the next slide.
So after getting our hands on the actual toolkit, we were able to get to work with calipers and model each one of these grapples in it's called Fusion 360. It's a cloud-based computer-aided design CAD software. It's available for students and non-professionals for free with some limited applications. And this is used to be able to create dimension-driven models as well as diagrams from these models to be able to be used for manufacturers. So you can see in the bottom left there is the standard grapple. We have the small grapple, single tine, and large grapple on the right there. Here with some of the stress testing or early efforts to be able to model stress testing. So this is a displacement test with 2,000 pounds of force. In that top right tine, you can see just the head of the arrow there pointing out. And we have a video that you can see just the next slide here. So here was just a preliminary sort of test with the model, modeling the strength of the steel with somewhat clumsy sort of force being pulled into that top right corner. You can see that it's deforming, and this just is showing how much 2,000 pounds of force would deform the tool itself by pulling on it kind of where the rope naturally sits during the proper sort of latching on in an entanglement. Moving on, we were also able to model the knives here, both the flying knife and the attached knife, and to be able to make the 3D models and the subsequent diagrams. So these are some of those manufacturing files, those diagrams. So this is still within the Autodesk Fusion 360 software. Those models are able to be extrapolated out into these side, front, back views, where we're able to get really detailed looks at the dimensions for these tools that engineers and fabricators can look at to be able to make exact tool specifications.
So going into materials exploration briefly, we were able to use, as I mentioned before, 3 different new methods of making the standard grapple. One being elastic resin, which is a 3D printed using a Formlabs printer for more educational purposes. But these were done in kind of almost keychain size form, but did a good job of kind of demonstrating the possible application of 3D printing. We also did one in a semi-flexible resin that demonstrates how a printable file can show what's possible in a harder material. But something like this could also be cast into stainless steel or aluminum. And then finally, we were able to make a mold and cast a full-scale standard grapple in urethane, which is super easy to reproduce in various materials, but also in itself could be used in an educational setting and could theoretically be thrown around in a gym classroom and not hurt anybody or damage any equipment. And here's just a couple slides as well of us doing these pours in our studio, and some images of the few iterations that we were able to do in the full-scale urethane on the right.
So our outcomes, we were able to finish our research with a suite of CAD diagrams and drawings that can be accessed by future collaborators, both disentanglers and other researchers for new manufacturers. We'd also be able to have a database of drawings that could be adjusted to suit region-specific needs. So for varying line thicknesses in different regions, these tools could potentially be altered in those dimensions in the software to reflect different tool-specific details. And lastly, we also have documented materials and fabrication exploration for future collaborators.
So ultimately, after spending the summer modeling and measuring these tools and meeting with regional experts, as well as at Lyman out in Hawaii, Peter Fulkins out in Monterey, California, more questions came up and more new ways we could help to advance these practical toolkit continue to arise. So one of our main outcomes was to really just lay out potential ways that this project could continue beyond the summer with adequate resources and allow us to do even more with what we have. Secondly, we recently became acquainted with Chris Bull, who's the director of the Brown Design Workshop, as well as part of the RISD Brown Masters of Design Engineering program, which we could use for both, and we could use this Brown Design Workshop for both additional fabrication and incredibly precise strength testing with their universal testing equipment. And finally, we believe that with the addition of 3D modeling into the field, like Fusion 360, as well as 3D printing, a singular database where drawings could live, be altered and easily reproduced by experts, as well as more low-tech disentanglers abroad, the field could gain an entirely renewed identity with more visibility and potential for federal grants. So as Max and I prepare to teach a course in this area of design in this January, we hope to continue working with Ainsley and David and use this as a case study for future need-based design projects. And we just want to thank you all so much for your time, and we'd love to open this time up for any questions you might have.
Thank you. And you can also reach us at our emails there. We'd be happy to hear any sorts of questions or any leads, any interest, please contact us. Thank you.